Hi there, welcome to the very first video mini lecture for AP Calculus. Throughout the course we're going to be using these video mini lectures to help you prepare as a student for class time with your pre-class work. This mini lecture is to expose you to the basics of the very first objective for the class this year, which is to find limits numerically. Before we find the limits numerically, we should talk about what a limit is. When you see notation that looks like this, what you have on the screen, the limit as x approaches c of f of x equals L. That is how we read that, by the way. The limit as x approaches c of some function f of x, some expression usually is what you'll see there, equals some value L. That's some value, that's some number. Okay? When you see that expression, it means that as x approaches c, as x gets closer and closer to c, you can interpret approaches to mean closer and closer, or excuse me, rather approaches means closer and closer. As x approaches c from both sides, and that's a key part of the expression here, meaning we have to see what happens as x gets closer and closer to this value c from both the left and the right. If the value that f of x is getting closer and closer to is the same from both sides, then we say that limit exists and it has this value. Here are a few more things that it may help to keep in mind regarding limits as you begin to talk about this idea. It always helped me to remember that a limit was a y value. When I'm asked to evaluate a limit in calculus class or in future mathematics, I'm looking for an output value, a y value. This of course assumes that y is your dependent variable, and if not, that's the variable you need to use here. Some of the limits can be found by just simple substitution, and I'll show you more about what that means as the next few days go on. And this is really the key here. The thing that you should definitely keep in mind is that there are several ways to find most limits. So over the next couple of class meetings, I want to show you and expose you to several different ways to find or evaluate limits. And I want to show you today what I think is probably the simplest one to prepare for. Okay, here's our first limit. We're looking for the limit as x approaches 2 for this function, and the function is x cubed minus 8, the whole quantity over x minus 2. Before, when we said that simple substitution could be used to evaluate some limits, it's the truth. But think for a second about what would happen if you were to try to just plug 2 in for x in this expression. In other words, if this is f of x here, if this whole expression is f of x, what's f of 2? That's essentially what I'm suggesting to you. If that value exists, if f of 2 exists, spoiler alert, that's your limit. That's the value you're seeking here. But if you were to plug 2 into this function, not only would the top be 0, 2 cubed is 8 and 8 minus 8 is 0, the bottom would be 0 as well. 2 minus 2 is 0. So simple substitution isn't really going to help us here. I want to show you the numerical method. The numerical method involves making a little table for yourself. And essentially it's a table of x and y values, or in this case I've written it like x and f of x values. The reason I chose these x values is because I truly do want to see what happens as x gets closer and closer to the value that we're seeking here, which is 2. So I chose a value close to 2, 1.9. Then I chose a value even closer to 2, 1.99. And then I chose a value even closer than that, 1.999, and etc. And that's probably enough values from the left side, from before 2. Now, since the definition of the limit said we need to check from both directions, I also did the same from the right side, from numbers bigger than 2. I picked 2.1. I picked a value even closer to 2, 2.01. I picked 2.001. So what I'm going to do now, using probably my graphing calculator or some other calculation resource, I'm going to evaluate all 6 of these. I'm going to take all 6 of these values, plug them in for x, and see what f of x would be. So I'm going to pause my recording really quickly, and I'm going to do that. And maybe you want to pause right here and try the same thing on your calculator and see if we get the same kind of values. Okay, I used my calculator to plug these values, these x values, into the function that we're trying to find the limit for, and I came up with these as the output values. And the only task left for me now is to figure out if I can use the information I just gathered to determine what happens to f of x as x approaches 2 from both sides. So if I look at what happens to the function values, the y values, as x approaches 2 from the left side, from numbers less than 2, I see a trend, and I think I know what value we're getting closer and closer to. When x was 1.9, y was 11.41. When x was 1.99, y was 11.94. When x was 1.999, we got 11.99. I think that from this direction, we're getting closer and closer to 12. And I think if I look from the right side, or in other words from values bigger than 2, I see the same trend. The closer we get to 2 for our input, the closer the output gets to 12. So I think, and I hope you'll agree with me, this table kind of clues me in on what this limit here is. The limit as x approaches 2 of x cubed minus 8 over x minus 2 is 12. And that, folks, is the numerical method for evaluating a limit. It's a very good, quick way, it'll be quick once you practice it a couple of times, to evaluate what a limit is using a numerical input method. I've got one for you to try now. So what I'm going to do is I'm going to ask you to try this one on your own. There's the screen cleared now. See if you can create a table using appropriate x input values, and then evaluate this function for those x values and see if you can determine what this limit might be. So what I'm going to suggest you do right now is hit pause, try to evaluate this limit, and then we'll work through it together. Well, here's the table that I created to try to evaluate this limit. I noticed that pure substitution would not work, because if I plug 0 in for x, both sine of 0 and 0, you'd get 0 over 0. Sine of 0 is 0. So just like the one we tried before, I don't get any kind of functional value out of substitution, but I can create a table that will let me kind of guess what this limit is, or to evaluate this limit. I chose this table with these values because I need to pick values that were both less than 0, like negative 0.1, negative 0.01, negative 0.001, and values that were bigger than 0, 0.1, 0.01, 0.001. Let me get some values real quick. Wow, well, here are the y values, the function values that my calculator gave me when I evaluated this function at these x values, and it's pretty clear to me what's happening both from the left and the right. We've got values very, very close to, and getting a little bit closer to 1 as x approaches 0 from the left side. We've got y values approaching 1 as x approaches 0 from the right side. I think we have the evidence we need to say that the limit as x approaches 0 of sine of x over x is 1. So I hope you were able to come up with that value with your work. Thanks for watching this video. I'm available if you've got questions or comments, and I'll see you very soon.